So while this is booting, I just got a notification. It says Supreme Court Justice Stephen Breyer to retire. So I remember, like, you know, when Trump was pretty much on his way out, he like basically appointed all of these, like, you know, Supreme Court justices and all these like Trump supporters, like in like all of these positions all over the country. And I know yeah, and I know that like everybody was kind of concerned about that, which, you know, I get it, because these people are appointed for life and they're there for a really, really long time. Okay, let me get these gentlemen. But yeah, I just got that notification. So I was like, okay, well, see, so now somebody's retiring. Oh, but you know what? I don't know if he was already somebody that was like, I don't know if he was like a Republican. I don't know anything about him. Let me see. So I don't know if that kind of shifts things a bit, but you know. But again, on the bright side, whether it's a Democrat or Republican, whoever, this is a lifetime appointment that Biden can set, right? So this stuff is like, it's like cutthroat and it's interesting. It's like a saga. And like, we're talking like the law of the land and people's lives. When I'm talking about in terms of like politics and things of that nature, it's just so interesting. And I feel like if, you know, as individuals, if we don't like do our part, like get in the game, then it's like I don't really feel like we have a place to complain, but at the same token, I get what people are saying in the sense of what's the point if you're going to be suppressed, and you know, it's like I get it, but in the same token, you still got to try, or just like break away from the system altogether. I'm taking attendance. It's the only delay that's going on here. It's just interesting. I'm probably more the type to just break away from the system and do my own thing. Okay, I think I can. Let me at least go ahead and share the screen, start the broadcast. And here. Okay, we'll start here. Let me see as far as announcements. Let me hit save over here. Okay, so this is what the top, no, the end for you guys. It's the end of week 3. So today we like to go through sections 1, 7, and 1, 8. 1, 7 is over the chain rule, and 1, 8 is over higher order derivatives. So with these past few sections, we've been exploring like basically the shortcuts and for taking the derivative. Again, all of these results that we get is, regarding the derivative tells us the slope of the tangent line at a point, right? So that's what the derivative is. And so we have these techniques and shortcuts for acquiring this. So we're going to explore more of these shortcuts today, the final set of 2. Right, so with that, and if you have questions, comments, or concerns, just feel free to unmute yourself to get my attention. Let me check one more time, because I know we have people kind of trickling in. What is this? The chat. Let me see. Group me. So yeah, hopefully you all, there is a group me. I encourage it. I think it's a good idea. I think it's a good idea for you all to be working together. So I'm just going to go ahead and kind of make my way through as many homework questions from 1.7 to 1.8. The full lectures for 1.7 and 1.8 are available. I'm doing my best to I try to stay ahead of you guys. Do have, I think, 2.1 and 2.2 and 2.4, because next week is in the school. We have, go fix that real quick. This week, so we have 4 sections. I kind of dialed back the work a little bit. And then the other piece of information is, so if this is what the end of week 3, I think our exam 1 for you also, we have 2 exams in the final, 2 exams for the entire semester in the final. Again, all the homework for the semester's up and running. It's already available, so you can actually get ahead, and I encourage you to get ahead on that as well. Only thing that you don't have access to are my exams. So exam 1 is scheduled to open. As a matter of fact, I think we can go ahead and pull it up. Let's look at it. Let's go to manage. Allow. Okay. So exam 1 is scheduled to become available right there. Week 6, February 14th, Valentine's Day, right? So happy, I guess what, Massacre Day, whatever, I don't know. But let's hopefully no massacres, right? So that exam is scheduled to become available on February 14th, and you'll have 7 days where you can earn higher than 90% or up to 100%, right? It's due February 21st, the beginning of Pisces. And again, with any assignment, we get unlimited attempts, and you can work on any assignment past the due date, but there is a 10% late penalty. So if you wanted to work on exam one past the 21st, you're welcome to as many attempts as you want. It's set to take your highest score. It's just that anything submitted past the due date is a 10% late penalty. But there's a hard deadline for all assignments. It's like May 1st at midnight, that Sunday night going into Monday at the top of the weekend finals, right? Okay. So let's do the best we can. Again, if you have questions, comments, or concern, feel free to unmute yourself to get my attention. And let's do the best we can to get through as many of these homework questions as we can, right? So this is augmented review. I'm going to actually skip this one because this is not necessarily section 1.7. I'm going to just get to this one from 1.7. And again, we don't have to go through these in particular. I'm just trying to work questions that are relevant to the section that you're in. So, okay, so 1.7 is regarding the chain rule. So in this example, I think I hit save there. Let me hit save one more time. Record this one. Yeah, let me move it on the screen. Okay. So so the chain rule, the way the chain rule works is it's like basically what you're doing the derivative of the outside function times the derivative of the inside function. That's essentially what the chain rule is, right? So let's go like this. Let's go a little bit further. I think this is okay. Matter of fact, let's go ahead. So we're gonna take some notes here. And again, everything that you see me writing, I loaded a copy of this. You can access it on our Blackboard page, okay? And like the recordings are on YouTube. So like basically Blackboard is our central hub for anything on Blackboard or this course. Okay, I'm gonna drop this right here. That's enough. All right, and let's do like this so it's just not waste so much. All right, so we actually differentiate. Now again, the chain rule, something like this. Again, it's the derivative of the outside function times the derivative of the inside function, right? So first thing I'm going to do is rewrite this so the outside function becomes clear. If we got square root, then the outside function, we're going to rewrite that square root as this thing to the power of 1/2, right? So then when we go to find dy by dx, basically the 1/2 comes down. So 1/2 comes down and we subtract 1 from the exponent, right? So then when we do that, and we also need to say times basically the derivative of the inside function, d by dx, we'll get it going. So if we bring the 1/2 down, the inside stays as is. 1/2 minus 1 is a negative 1/2. Now we're going to say times the derivative of the inside function. The derivative of x squared is 2x, and the derivative of a constant is 0. Right? And then let's just kind of combine like terms and simplify. So this half turns this 2 into a 1. And then ultimately we get on the bottom, we get the square root of x squared plus 2. My dog is pacing. Man, it's always something that's making me anxious. Last time it was my neighbor tap dancing upstairs. Now my dog wants to like pace. I don't know. I think she's just waking up. So she's just like, full of energy. I probably need to take her for a walk. Okay, let's submit this. And then I got laundry going in the back. So that's a lot of noise, but it is what it is. Man. But we're here. Yeah, we can see our result. Let me see here. I think we just got to zoom out. Okay. I don't know if any of you guys ever watched like Cowboy Bebop, but I just finished the live. I never could get into the animated series. I kept trying and I just couldn't get into it, but I always felt like it was a good series. I just never watched it. So I watched the live one. I actually enjoyed the live ones. Spoiler alert. You know, I don't really want to say it. So now let's do a fraction. We have an x on bottom. We have plus 2. Okay, that's it. All right, let's try another one. I'm going to suppress this. Well, actually, I'm going to leave that. We're asked to differentiate, so let's take some more notes. More notes. More. Okay, I think everything's still running. Okay, let me get a copy. And I just like to get the header so that way we know where we're getting this question from. Next, come on. We're in question. Okay, let me suppress this now. There's good. And we're going to take you and go through here. All right. Okay, so we're asked to differentiate. So we have a couple of rules going on here. All right. So we're going to, long story short, we're going to be using the product rule in conjunction with the chain rule. And we're going to be using several rules at once, right? So the main one is the product rule. We got something times something else. So the way the product rule goes is the first times the derivative of the second plus the second times the derivative of the first, right? So then when we go to find dy by dx, the first, which is this thing, times the derivative of the second. Now, when we take the derivative of the second here, just to get it to stand out a little bit more, let's do times d by dx, or the derivative of the second thing, all right? So we haven't taken the derivative yet. Okay. So we said the first times the derivative of the second plus the second, which is this, times the derivative first, d by dx. And the first thing is this 4x minus 2 quantity squared, right? I kind of ran out of space. I'm just going to shrink this down and get it on one line. Okay. It's decent. And then I'm just going to expand it back. So I'm just using the fact that I'm writing on a digital platform to move stuff around, okay? So we said the first times the derivative of the second plus the second times the derivative of the first, okay? So now we get, so the first just comes down, it's 4x minus 2 quantity squared. So now the derivative of the second part, you got to use the chain rule. So this 2 comes down and we subtract 1. So then we'll have 2 times 5 minus x to the 5th to the power of 1. Then we have to say times the derivative of the inside. So again, chain rule is the derivative of the outside function times the derivative of the inside function. So we're going to say times the derivative of a constant is 0. The derivative of this guy, the 5 comes down and we subtract 1, right? So we'll get negative 5x to the power of 4. Okay. I'm just going to write plus and just use the next line because I'm again out of space. 5 minus x to the 5th quantity squared. Now the derivative there, again, chain rule, the 2 comes down. We rewrite the inside, so 4x minus 2. Then we say subtract 1 from the exponent is a 1. Times the derivative of the inside function is times 4. Okay. Let me shrink this down again and get it on one line. And again, like I told you, my dog is gonna sleep all day. I go to stream, and then she's like, "Oh, let me warm up my vocal cords." It's just hilarious. Okay, like with this stuff, even though it's frustrating, I mean, you can't really control these other beings, as much as we might like to try to. Like that's part of the psychosis, in my opinion, or delusion of much of society. We don't see like we don't acknowledge certain like divine laws or natural laws. Like when you start to impose your will on others, that's breaking a divine law. So then don't be surprised when like the shit goes sideways, right? Because you're working against the natural law of divine law. So it's like me trying to like, even you as my students, I'm not trying to tell you what to do. I'm like saying, hey, this is the playing field. This is a suggestion. I'm just here to help you, really. But I don't have no one has a right to tell anybody else about themselves. Like I feel like everybody knows what's best for themselves. You know what I mean? Even my little dog over there, she's losing her mind. As frustrating as it is, she wasn't working every little thing. But there was this time, for instance, we're sitting in a yard, right? Just in an open field, on the edge of the forest line, right? So the trees are maybe 6 feet ahead of us, but otherwise we're sitting like in a yard. And then out of nowhere, she like, what did she do? She just like takes off and she's barking at something off in the distance. And I'm like, yo, stop barking, calm down, come over here and sit down. And she just would not stop. And I'm up here fuming. So then I'm like, okay, I finally was like, okay, fine. I get up and I was like, if you don't come here, I had full intention of like, what is it called? Like disciplining her, like basically giving her a spanking, right? As soon as I get up and I take a few steps, this large branch shatters and falls and lands right where I was sitting. I was like, oh, I see why that was going on. I was like, okay, so I was totally in the wrong. Like if I didn't get up because of that dog, that branch would have definitely fallen on my head. And that could have been, it was a huge, huge branch. It would have caused some serious damage. So it's because of it. I've had several experiences like that where, you know, just learning how to trust what's going on. Because like the thing is, my mind, it thinks it knows everything, where it be having so many blind spots. My mind being unaware of so many things, but the rest of my body is aware of these blind spots and it's trying to alert me, say, "Hey, stop listening to your mind. You need to be here." And so then, so I kind of abandon logic at times and just kind of trust the universe. And the next thing I know, it works. I'm like, oh. So logic is one realm, but that's not all there is. I used to live by logic. Like if it didn't make any sense, I wouldn't do it. But it would always kind of, again, I had blind spots, so I was missing stuff. But now what I do is I use my logic in conjunction with filling it out, in conjunction with my intuition. And I feel like, you kind of need both, you know, to kind of navigate this realm. So again, all that came out of, you know, basically not trying to control others, not trying to impose your will on others, and that whole discussion, the blind spots of logic, and the illusion of trying to control anything really in this realm, others or situations or events. And again, even though they're frustrating, the sooner you can kind of acknowledge them, acknowledge how they make you feel, and accept it, the better off you'll be. But the more you try to like force things, like if you find yourself trying to force something, more than likely you're not doing something right. But I'm just speaking in the sense of well-being. I'm not speaking in the sense of success and capitalism. That's a different energy. You walk that path. I walk a different path. Well, I still intend to be successful and have all that stuff, but that's going to be a byproduct of what I'm doing. But anyway, that's all. Man. Let's get back on task, right? Again, my favorite thing to do is go on tangents. Okay, so we are here, right? Okay, so let's kind of back up a little bit. We said the first times the derivative of the second, so the derivative here plus the second times the derivative of the first. Okay, so we can simplify a good amount of this down. Let's see, we got 5 minus the x to the 5th. That occurs twice. Let me highlight that, right? So we got this thing and this one. They occur twice, right? So that's there. They both have this guy, that one, and this one. I think I can let it go. This style, we'll do this one, right? They both have the green thing. So I highlighted those because we can factor those out, right? So then let's do like this. So if we factor out the green thing, we'll have this 4x minus 2. We could factor out, let me see, they both have at least one of those. We can factor out this blue thing. They both have at least one, so 5 minus x to the fifth, right? So let me make some notations. This one is gone. This one, instead of being a 2, goes to a 1. This one is gone. This one goes from a 2 to a 1. Okay, so then let's write what's left over. So now in the first part, it looks like we have the green thing, and this 2 times this -5. So we have, matter of fact, it looks like we can factor out a 2 as well. Let me see, I'm going to highlight this guy, style. We can do this color. Okay, so let's factor out that they both have at least 1 2 as well. All right, so let's factor out that 2. I'm just going to put it in front of the green thing here. Okay. So if we factor out the 2, this 2 has been accounted for, this 2 has been accounted for. So now if we write what's left over, in the first part we have, let me see, there's -5x to the 4. You know what, and I might be doing, sometimes with these I tend to go a little bit further than they want, which I might be doing here. Let's see, in the second one, 4 times 5 minus x to the fifth. Okay, I think I got everything. We could expand this and combine like terms. I'm going to go a little bit further just because that's what I feel inclined to do. They may have stopped further, closer to like, trying to find the color I haven't used. Here, I just use this. Right? They may have stopped on this line, but I'm gonna do one more line. We have this 2 times 4x minus 2, 5 minus x to the fifth. I just kind of brought all that down. And then here, if we expand, that's going to be a -20x to the fifth plus 10x to the 4 plus 20 minus 4x to the fifth. Are there like terms there? There's a set. One more step. 4x minus 2, 5 minus x to the fifth. Now we got an x to the fifth here and here, right? So that makes a -24. -24x to the fifth. 10. Looks like there's a 2 in there as well that we can factor out. 10x to the 4 plus 20. Okay, let me 2. Is it 12? Okay. Let me factor out one more 2 from all of those. So this will be my final answer here. 4x minus 2, 5 minus x squared. Now if we factor out that 2, we get -12x to the fifth plus 5x to the 4 plus 10. Okay. All right, let's try this and then see if we can get this one correct. Because I feel like the challenge here is just, okay, being clear about where it is they want us to stop. And when I was kind of working some of these before, it seemed like it would kind of change from question to question. Okay. So we get all of this. Okay. So we're gonna hop back. Okay, hopefully you guys can hear me. I think you can. Let me see. I think I might need to. Did I lose my live stream? Nope. It seems like the live is still going. I need to share my screen. Start the broadcast. Okay. We left off here. Okay. So we can see basically it's a similar form as what we got. So we're just going to go with the result that we got. Okay. That makes me confident. So because of this thing, come on, close. I think part of the glitchiness is because I'm working on my iPad. I think it might be over. Okay, let's go. There we go. Close. 4, right? Parentheses. 4x minus 2. So 4x minus 2, that's a 21. Parentheses. 5 minus x squared. Okay. Parentheses. Then we got negative 12x to the 5th, negative 12x to the power 5, plus 5x to the power 4. Okay. Plus 10. Cross our fingers. Oh, okay. And now we got to try to go through and see, can we find the error? We factored out the 2, 12, 5, 10. 4x minus 2, 5 minus x squared. Okay, let's go back to our work and see if we can find, let me check one more time. 4x minus 2, 5 minus x squared. Negative 12x to the 5th, 5x to the 4 plus 10. Okay, let's see if we can find the error. So now this is like where the challenge comes in. So the first, here, I can leave that for now. So we said the first, which you see here, times the derivative of the second. Let me see. Here's the first. The 2 comes down, 5 minus x to the 5th, times the derivative of the inside function, negative 5x to the 4, right? So I'm confident in this part. Plus the second, 5 minus x to the 5th, call it squared, times the derivative of the first. The 2 comes down, 4x minus 2. The derivative of the inside is just 4, right? So I feel good about this one. Then from there, we factored, right? So we factored out, they both had a 2. We highlighted it in purple, so you see it here. They both had the green thing, right? You see it here. And they both had at least one of the blues. You see it here, right? So now in the first one, we still had that 4x minus 2 and the negative 5x to the 4, right? You see it here. I think those are the only 2 pieces that were left over there, right? In the second part, we had 4 and the 5 minus x to the 5th, okay? So I don't see anything there. I'm fairly confident in this part. So then, with what was left over, I think we got this already, right? Let's see. Now, if we distribute, 5 times 4 is a negative 20, positive 10, x to the 4. 5 times 4 is 20, negative 4x to the 5th. Okay. We factored out, well, we combined like terms. This and this gave us a negative 24, 10x and 20. Maybe we could have factored out a -2. That really shouldn't change anything. If we factored out a -2, would that should still be good enough. 5 minus. Oh, there it is, right there. I found it. I should have gave extra credit for that. So the error is right here. But up. When we went from here to here, we wrote a squared instead of fifth, right? So that was supposed to be a 5. I think that's it. I'm gonna make that change. Hopefully that's it. That's the thing. You just have to be meticulous and slow and neat and organized as you can be, because that wasn't even a calculation error. We just copied wrong, right? So then right here, that should be 5. Cross our fingers. Let me check one more time. All right, we're gonna go with it. Going once, going twice. Man, but that's what happens. Like, just again, if what you just experienced, that's why I don't do these in advance, because you need to be aware of that thing when it doesn't work out. Like, for instance, if this were, I would be open to giving partial credit for something like that. Like, if you got an answer and like we put if you can either find your mistake and correct it and show me the correct answer, or if you could just find your mistake, I would be open to not extra credit, but partial credit for things like that. So like if you're working through the homework, you get something wrong, maybe not the homework, more so the exams is where it matters. The homework is a lot of work. The homework is really there to just prepare you for the exam, right? I think the homework for the entire semester might be 7.5% of your overall grade, and the quizzes might be 7.5%, something like that.
So what would you? Good evening, Professor.
Greetings.
I was gonna ask you. So what would you think the most important thing to pay attention or do well on in this class is?
Basically, do the assignments on Pearson. So the homework, it's a lot of work, but the points are low. But it's the most important thing, right? Because when I go to make your exam, I mean, basically all I did, I went through the homework and 4 questions from the homework, and those are your exams. And I just kind of keep shuffling the homework questions, just in a testing scenario. So basically, you just want to do your best to process the things that are assigned on Pearson as best you can. And you get unlimited attempts. Just get those scores to where you want them to be. You can honestly work with like tutors. You can work together. I encourage it. It's still a lot of work, right? And everybody needs to submit their own work. Okay. So yeah. Hopefully you guys can still hear me. I had to change out my headphones. Let me see. I think we're okay. Okay. Yeah, that was an adventure. So I'm gonna suppress that for now. I just had to take a quick break. That was nice. Let's do another one. Let me see the time. Are we halfway? We are essentially halfway. Okay. So I'm gonna go ahead and step out of 1.7 and let's move on to section 1.8. So this one, let's go to view. Allow. My alarm should be going off momentarily. Let's see, we said 1.8, so this is week 3, right? The end of week 3. Okay. Stop, thank you. And then 1.8, higher order.
Professor, I have one more question.
Sure.
I just got transferred into this class on Monday. Yes, okay. Yes, so I just got transferred into this class on Monday. So my name is Christopher Jones. I was wondering, is there anything that I need to we can probably discuss it after class, as a matter of fact.
Yeah. Just catch me towards the end of class. So if class gets us at 7:15, I usually stop around 7:10. So if you can remind me about 7:05, that's a perfect time to talk about this. Okay.
Yes, sir.
All right. Yep. So with section 1.7 was on a chain rule. We saw a few examples of the chain rule. It can get kind of dicey fast. So again, because we're going through so much work, what I ended up doing was basically cutting the assignments in half, so it's not so much work. Again, the idea behind this, we have a lot of sections that we need to get through, and so I just want to kind of touch on these concepts, and you just have to do the best that you can, right? So I try not to give so much work. So then with section 1.8, 1.8 is centered around higher order derivatives, right? Where higher order derivatives, like, so we've kind of gone through, like, I think all the shortcuts or most of the shortcuts for differentiation. So now higher order derivatives is basically like taking a derivative of a derivative. So you have a function, you take a derivative, you get an answer. Then suppose you were to take a derivative of that answer, you get another answer. And then how many times can you take the derivative of the derivative, right? So that's what we mean by higher order derivatives, right? And there are different properties that come out and things that come out, okay? So in this example, we're asked to find the given limit. Actually, I'm gonna skip this one because this is like a recap from a previous topic. This comes from section 1.2. So I'm gonna jump to a question that comes from section 1.8. This is still 1.7, which is a chain rule. Here we go. Here's the first question from this assignment that comes from 1.8. So we have this, find the second derivative of v with respect to t. So in other words, it's asking us to find the second derivative. So all we're gonna do is take the derivative like normal, and then whatever answer we get, we're gonna take the derivative again. Let me start by getting a copy. I think this is probably ideal. And then let's go like this. Also, so that people are aware, I am live streaming this to YouTube. So I do the best I can to like be cognizant of people's sensitive information. I just want you to know. Oh no, I know. Okay. I just want you to be aware that I am live streaming this to YouTube, and like pretty much all of our sessions. Basically, Blackboard is our central hub for everything. When you log into our Blackboard, the first link I think is a Zoom link. So if you made it into my Zoom, you're already, ahead of the game. That means you know how to reach me. The second one is our box link, I think it is. It's like basically when you're on Blackboard, that second link is where I dump any PDF. So like all the stuff that you see me writing, I make a PDF version of it available. Actually, the blank set of these notes, when I'm creating them, I load the blank set of notes there, and then after I finish doing the handwriting, I load the handwritten notes in Blackboard as well. So you have access to the blank notes and the handwritten notes afterwards. And then I think the third link might be our assignments with Pearson. So you kind of go through there and just follow the prompts. You access Pearson from our Blackboard. I basically linked it to our Blackboard. And then the fourth link on our Blackboard page it takes you to my YouTube channel. So go ahead and like, share, and subscribe. Turn on all your notifications, so that way when I post things, you can at least see when I'm posting. And honestly, when I post, a lot of times I go through my Zoom. So if you want to like just ask me something, we can use that as an impromptu office hours if needed, right? A lot of times I'll go live to like do my recordings, the lectures for you and my other class. But yeah, so that's pretty much what I would say at the end. Is basically Blackboard is our central hub for everything. That's why I put all those links right there. Okay, so let's start here. So we have v in terms of t. So if this is basically saying find the second derivative. This is Leibniz notation. This just means find the second derivative of v with respect to t. That's how this is read, right? So first, let's find dv by dt, the derivative of v with respect to t. Okay, so we just differentiate like normal. For that first term, the 2 comes down, so 2 times 2 is 4, and then 2 minus 1 is 1. So that first term just becomes 4t. The second term, the 1 comes down, so 1 times 8 is 8, and then 1 minus 1 is 0. So the derivative of 8t is just 8. And then for that third term, the derivative of a constant is 0, right? So you definitely want to go back and just make sure that so my recommendation is just, you want to go through those previous lectures if you haven't seen them, and take notes as if you're in class. I'm pretty sure there is a group me. I do encourage you all to work together. And I also encourage everyone to go ahead and seek out the tutors, and you can sit down and work on this with them as well. You've already paid the tutors. They're included in your tuition. So when you don't use them, you're pretty much just throwing money away. If you want to throw money away, feel free to just throw some my way. I can't help you out for this semester, but I'm not going to turn away money. I don't do bribes either, but I don't do that kind of stuff. But after all is said and done, if you want to just give me some money, I'm not gonna refute that or anything. Okay, so this is the derivative of v with respect to t, right? But so then now we want to just take the derivative of this answer. So we want to do the derivative of this thing, right? So the second derivative of b with respect to t, right? So basically take the derivative of the above answer. So the derivative of this guy is just 4, right? And again, the derivative of a constant is 0. So the second derivative of the original function is this guy here. It's just 4. Okay, and that's just how this one happened to work out. Okay. So let's hop back over to here, right here. Let's see. What if I like
Let's see. If you can hear me, can you go back to that problem? By the way, I can't hear you if you're talking.
Professor? Hello, Professor?